Imagine this. A thermal camera shakes in the dark. A soldier lies on the ground, his torso almost torn apart by an explosion, his organs exposed, the last heat of his body drifting away in slow pulses of red. In any normal world, he should already be gone. Except he isn't. Something impossible begins to unfold. The torn flesh quivers, the edges pull together, and the cells rush in like workers returning from a break. They stitch the tissue with a precision no surgeon could match. The skin thickens, the vessels reconnect, and the wound seals itself as if the body has just remembered an ability it should not have. 3 minutes later, the man lifts his head. No miracle, no myth, just biology behaving in a way it was never designed to. Now imagine someone watching this beside you and saying, completely calm, there is a real American project trying to make this possible within this decade. Its name is DARPA, the Defense Advanced Research Projects Agency. This isn't superhero science, and it isn't a midnight conspiracy born on a forgotten forum. This is a classified ambition. The idea is simple and terrifying. Erase the line between being wounded and being whole. In this episode, we step into a world where secrecy is normal, where ethics bend under pressure, and where the human body becomes a technological platform. We will explore programs buried under layers of classification, experiments that will flirt with illegality, attempts to push tissue to regenerate at impossible speeds, and technologies that will step out of science fiction the moment DARPA decides they shouldn't stay there. DARPA does not look at the impossible like the rest of us. DARPA treats it like a malfunction, something to correct. Instead of asking, can we do this? DARPA asks, how long will it take? The goal is no longer to build stronger soldiers. The new goal is far more radical. Make death unreliable. Turn fatal wounds into temporary glitches. Treat the human body like software. Transform mortality from a destiny into a technical limitation. And here's the part that concerns you. The internet, GPS, and modern AI all started in military labs before quietly moving into everyday life. What begins on the battlefield has a habit of showing up in hospitals, homes, and pockets. If bodies can regenerate, civilians will want it. If trauma can be reversed, medicine won't have a choice. This isn't someone else's future. It's the update you didn't ask for. Before we open the door to the lab where this transformation begins, take a moment to subscribe. One day, if your organs ever decide to quit early, you might be glad to know how to bring them back online. Now comes the question that changes everything. Not a name, not a face, a moment. Somewhere in the American chain of command, a realization took shape. A quiet shift in perspective. The idea that DARPA shouldn't just help soldiers survive, but regenerate. Someone looked at the limits of the human body and wondered if those limits were truly fixed, or simply inherited. That's when survival stopped being the goal, and regeneration became the objective. To get there, they did what science always does next. They turned to nature. To understand where all this began, you have to picture a scene that feels almost mythological. Long before scientists tried to rebuild human tissue, nature was already doing it effortlessly. Salamanders regrow entire limbs as casually as we trim our nails. The axolotl can recreate part of its heart after an injury, as if its organs came with a repair mode. Some jellyfish press a biological reset button and return to a younger state, skipping death entirely. There are rats capable of reconnecting damaged neurons, And hidden inside all these creatures is the same secret question: why them and not us? These observations fascinated biologists for decades, but it wasn't until military strategists joined the conversation that everything shifted. The idea of regeneration moved from curiosity to opportunity. Early military programs already aimed to reduce battlefield losses, but they were stuck within the limits of ordinary medicine. Bandages, field surgeons, helicopter evacuations, all fragile, all slow, all dependent on a biology that breaks too easily. Then came a moment that still echoes today. In the early 2000s, during a closed-door briefing, a high-ranking general studied the data on regenerative species. After a long silence, he asked a simple question that changed everything. Why does nature have regenerative abilities and humans don't? A scientist answered with the kind of calm that makes everyone else feel slightly behind. Because humans lost those abilities during evolution, but nothing says we can't turn them back on. That sentence became the psychological seed of the entire project. It reframed the question. It wasn't, can we heal faster anymore? It became, how far can we push life before it breaks? And suddenly, biology wasn't a passive system to protect. It was a platform to upgrade. Researchers began to study salamanders not as animals but as models. Axolotls became blueprints. Immortal jellyfish became roadmaps. Every species with a strange talent started to look like a missing instruction manual for the human body. The military didn't see them as creatures. They saw them as prototypes. And as the ambition grew, so did the stakes. Because pushing the limits of life comes with a price. Cells that regenerate too fast can become cancer. Tissue that closes too quickly can trap infection. A body that heals like a machine risks behaving like one. The suspense rose in secret meetings, scientific memos, and late-night debates. How far could they go before the human body stopped being human? And how far were they willing to push to find out? That's the moment when DARPA stepped into the story. And when DARPA enters, everything accelerates. Budgets expand, boundaries soften, and the ethical alarms start ringing in rooms where no one wants to hear them. Because from this point on, the project is no longer a scientific question. It's a military objective. Now the story leaves theory and steps into the lab, where biology starts behaving like a rebellious machine. Everything moves fast, almost too fast, as if the living world itself were accelerating. In one room, human tissue grows in culture dishes and repairs itself 30 times faster than normal. Scientists watch the cells close wounds in minutes, not hours, and they whisper that it looks almost impatient. In another room, a sheet of artificial skin receives a test shot. A metal pellet tears through it, leaving a clean hole. 5 seconds later, the hole closes with a slow ripple, like liquid tightening into solid form. Nearby, researchers examine cells that repair broken DNA in real time. Under the microscope, damaged strands knit back together with a speed so unnatural it feels like watching film played in reverse. Down the hall, organs from test animals begin to regrow. Not fully, not perfectly, but enough to prove that regeneration can be pushed far beyond its natural limits. A heart that partially rebuilds, a liver that fills its own gaps, a spinal cord that reconnects a few lost pathways. And then come the prototypes, living constructs, half research, half science fiction, organisms modified to test healing cycles, immune rewrites, and tissue patterns that do not exist in nature. Some barely survive. Some survive too well. A few are quietly archived in reports no one will ever see. But every breakthrough comes with its shadow side, and the shadows grow darker with every experiment. Some organs regenerate too quickly and collapse into massive tumors. Some cell lines become immortal, then switch into explosive cancers. A few animals heal so aggressively that their own metabolism burns them out, leaving bodies that look repaired on the outside but fatally exhausted inside. Other creatures enter regeneration loops that never stop, their tissue closing, reopening and closing again like a machine stuck in reboot. The worst failures come from implant tests. Living patches meant to repair bone or muscle suddenly mutate. They twist into shapes that do not match any known structure, forcing the team to reconsider what happens when you give biology too much freedom. And somewhere in that storm of progress and disaster, someone tries to lighten the mood. You wanted Wolverine. You get a rabbit that over-regenerates its own ear until it looks like a PlayStation 2 glitch. But behind the jokes, one truth becomes clear. DARPA didn't want to heal soldiers. DARPA wanted to rebuild them, piece by living piece. And the real nightmare begins when the military walks into the lab, examines the results, and asks the question everyone feared. Where is the human version? This is the moment where the project stops being a scientific curiosity and becomes something far more serious. Regeneration is no longer a theory on a whiteboard or a miracle seen under a microscope. It becomes a tool. And tools, in the military world, never stay harmless for long. The first prototypes are discreetly tested on volunteer soldiers. Nothing dramatic at first. Just a thin artificial skin grafted on the arm, almost invisible. During the test, the researchers make a controlled incision. The wound closes before anyone can take a proper picture. The soldier stares at his arm, waiting for pain that never comes. He asks if the test has even begun. After that, the team escalates. They implant living structures designed to rebuild bones. These implants sit inside the body like quiet engineers, waiting for a fracture. When one occurs, they activate instantly, growing new bone along the crack, reinforcing the structure faster than any cast or surgery could. Then comes the creation of instant coagulation systems, fluids that harden the moment they touch blood, microstructures that wrap around a damaged vessel and close it like a knot. A soldier who would normally bleed out now survives with a heartbeat barely disrupted. As soon as these tests succeed, the entire tone of the program changes. Field medics begin using early versions of gene therapies directly on deployment zones. Soldiers receive injections that tell their cells how to behave under trauma. Some regenerate muscle overnight. Others recover from concussions with a clarity that terrifies the doctors observing them. Meanwhile, nanobiology becomes the new frontier. Researchers create microscopic machines meant to swim through the bloodstream and repair tissue from the inside. Early models malfunction, often disastrously, but each iteration gets closer to something functional. The idea that a soldier could carry a swarm of internal healers becomes less science fiction and more a matter of budget. Slowly, reports start to look different. Less about healing and more about upgrading. Words like autonomous repair cycles, genetic override, and tissue acceleration protocol appear on every page. The soldiers undergoing tests begin to feel like prototypes. Some whisper privately that they no longer know what part of them is natural. Then the meetings begin. Behind closed doors, defense managers gather around tables covered with confidential documents. They review footage of soldiers healing in seconds, They read notes about bones repairing themselves overnight. And someone finally asked the question everyone avoided. If a soldier can survive anything, should we still consider him human? The silence that follows is long and heavy, because the implications are enormous. A soldier who cannot be killed is no longer just a soldier. He becomes a piece of equipment, durable, repairable, deployable. The line separating a person from a tool begins to fade. For centuries, armies feared losing men. Now they imagine men who cannot be lost. It changes everything: how you train them, how you use them, how you think about them. Some ethicists warn that creating soldiers who heal too well will strip them of basic rights. Others fear a biological arms race. Nations competing not for weapons, but for bodies engineered to endure anything. Inside the program, scientists feel the pressure. Some are excited, others are deeply uncomfortable. But they all share the same realization. They are no longer working on medicine. They are working on control. Control over biology, control over life, control over death. In the laboratories, jokes circulate to release the tension. When your employer invests millions so you can survive a missile, it's rarely because they want you to take a long weekend. Behind the humor, the truth is obvious. DARPA never intended to simply heal soldiers. DARPA intended to rebuild them, change them, sculpt them into something that no longer fits the definition of human. And the real turning point arrives when the military stops asking whether the technology works on animals or volunteers, because they start asking something far more disturbing. Where is the human version, and when can we see it in full? What comes next crosses every limit imaginable. Now we step into the future that DARPA is quietly assembling. A future where the soldier is no longer just trained or equipped, but engineered. Every part of his body becomes modifiable, adaptable, and ready to repair itself faster than it breaks. The first breakthrough is the skin. Not just regenerative, but self-cleaning, resistant to infection, and capable of sealing a wound in seconds. A cut becomes a ripple. A burn becomes a brief flash of heat. A bullet hole closes before the shock even reaches the brain. Then come the organs. Reprogrammable hearts that adjust their own rhythm after trauma. Livers that detoxify faster during stress. Lungs that expand or contract depending on oxygen levels. Smart enough to save a life without external help. Inside the cells, a new logic appears. They align and behave like software following a script. If the program says repair, they repair. If it says reinforce, they reinforce. Healing becomes a command instead of a hope. The bones evolve too. A biotech skeleton capable of patching itself mid-combat. Microstructures grow along fractures in real time, turning what used to be a catastrophic injury into a temporary inconvenience. The brain receives its upgrades as well. Stabilizers that reduce concussions, microshields that protect neurons, memory circuits protected from shock, decision-making preserved even under extreme trauma. Muscles transform next. Soldiers receive a biogel that enhances recovery. Torn fibers rebuild overnight. Fatigue becomes rare. Endurance becomes a baseline, not an achievement. And then comes the strangest creation of all, living exoskeletons. Structures fused directly to the body, half biological, half engineered. They amplify strength. They reinforce movement. They heal when damaged, just like the flesh beneath them. This world opens two possible futures, one that feels bright, one that feels cold. The utopian vision is seductive. 0 battlefield deaths, medics replaced by rapid biological updates, amputations abolished, civilian medicine transformed by discoveries born in military labs, diseases beaten by regeneration, paralysis reversed, life extended for millions. It's a future where war harms no one, because bodies refuse to break. But the dystopian vision is harder to ignore. Soldiers who can be repaired infinitely become soldiers who can be used infinitely. Human beings turn into living equipment. War stops being about loss and becomes about durability. A conflict that should end keeps going because the bodies fighting it no longer fall. The battlefield grows larger, longer, colder, and the technology that rebuilds the privileged becomes a commodity sold to the highest bidder. Regeneration turns into a resource, maybe even a luxury. Perhaps only those who can pay will heal like gods. And somewhere inside this dark future, a quiet absurdity persists. Imagine taking a bullet, watching your wound close itself, and hearing your medic say, "Hold on, just restart. The update needs a clean reboot." The joke hides a reality. A body that can be reprogrammed can also be controlled, directed, limited, overridden. And that leads to the final question, the one that sits at the edge of everything humanity is becoming. Are these future soldiers immortal, or prisoners inside bodies rewritten like machines? We return now to the first image. A soldier on the ground, gravely wounded. A body pushed beyond what medicine once considered survivable. And yet, something unexpected happens. The skin begins to close, the organs reconnect, the body stabilizes. Not through magic, not through myth, but through biology, doing something new. Everything in this story converges toward that moment. Regeneration, living implants, nanobiology, bioengineered structures that assist healing instead of replacing it. Each experiment, each iteration, successful or not, has moved us closer to a simple idea. The human body may not be as fragile as we once believed. And that realization doesn't belong only to the battlefield. The question that emerges is no longer dark, but profound. If the human body can repair itself beyond its natural limits, what becomes possible? For most of human history, injury meant decline. Trauma meant permanent loss. Medicine focused on managing damage, not reversing it. But technologies born in extreme environments often escape their original purpose. The internet did. GPS did. Modern artificial intelligence did. And regenerative biology may follow the same path. DARPA did not just explore survival under fire. It explored how tissues communicate, how cells coordinate repair, how the body can be guided instead of overridden. Those same discoveries point towards civilian futures that feel almost inevitable. Faster healing after accidents, organs repaired instead of replaced, neurotrauma treated at its source, aging slowed by improved cellular maintenance, recovery measured in days instead of months, not immortality, but resilience, not invincibility, but continuity. A regenerating soldier becomes less a warning and more a preview, a sign of what happens when biology and engineering finally learn to speak the same language, a demonstration that the body can be supported the way software systems are, updated, stabilized, optimized, without losing its identity. This doesn't erase mortality, it reframes it. Death remains real, but no longer arrives by default at the first failure. Life gains margin, time gains flexibility, medicine gains leverage. Every major leap in science has raised the same question. Not only can we do this, but what will we do with it? And history shows that when technology leaves the lab, it rarely stays exclusive. What begins as necessity often becomes opportunity for everyone. So now, the future opens quietly in front of us. Would you want to heal faster than ever before? Would you trust a medicine that repairs instead of replaces? Would you accept a world where survival is no longer a matter of luck, but of design? Tell us what you think. And see you soon for another wild ride into the brilliant, surprising, and very real future of crazy science stories.